Dear students, we are going to see the second unit. The second unit is entitled Statistical Model and Simulation. So here we are going to use statistics and probabilities in simulation. So this type of simulation is going to be using mathematical concepts. So here we are going to have some terminology and concepts in this scenario. The first one, we are going to see what is called discrete random variable. A discrete random variable. A discrete random variable, you can have an example. We are having x in uppercase. We call it a random variable. A random variable, it means it is a variable which can take random values. It means values which can be taken randomly. So for example, now you are having a variable x can have 5. Then the next value which will be held by this variable cannot be known in advance. So you don't know. It can take any value from the numerical numbers. So here x is a random variable which can hold any random values. If the number of possible values of x is finite, if we know the number, the expected number of value which can be held in x, it means it is finite. So it means that x will be called a discrete random variable because it can hold a known number of values. The possible values of x will be listed as x1, x2 in lowercase and so on till xn. The possible values that a discrete random variable x can take will be called the range space of x. This is the range of random variable which can be taken by x, and the range of those values will be called Rx. The probability that a random variable x takes the value xi can be replaced by any numerical number, For example, it can be x0, x1, x2, x3. So the probability that x will take a value x0, for example, I am having a different range of numbers, and then let's see an example here. I am having xi like this, xi. So I'm having xi. This means that I can hold a range of value from 0 to n. So for the first value, we can start from a0. Later we start from a0. Then the next value will be a1, a2, a3 till a10. So here we are having n will be equal to 10, the last value. So I will take the value from the range 0, 1 till 10. So this is called range of x. This is the total number of value which can be held by x. So here we are having the range of space of x, and it will be denoted Rx. So here what we are talking, this is like numbering. This is numbering. So I can say, for example, here I can type x1, x0 is equal to 5, and x1 is equal to 6, and x2 is equal to 7, and you go on till x9 is equal to 10, for example, like this. So you see, for each value, if I am at x0, I already know the value which will come next. So if the number of value, if we already know the value which will be taken from by a variable, we know it in advance, we are going to say that the x is a random variable, because the number of variable is finite, or of values. So here we are having 10 values. It means that it is a number of values which is finite. We already know it, so this variable x will be called discrete random variable. So the probability that a random variable x takes the value xi is denoted by pxi. It means that the probability that the random variable x takes the value 7 is going to be called pxi. So what is pxi here? It means that it is px7, like this. Px2. Px2, it will be the probability that pxi, it means px2, the probability that px2 will have a value 7, we will call it px2. So px2, it is the probability that the value x will hold a value x, a value 7. It means that, what does it mean? It means that there is a probability that x can hold any value from here. The probability that x can hold the value 5 is called px0. Px0, it will be equal to 1 out of 10, because to hold the value 5, because we know the number of values which is finite, the probability to hold the one value, it is 1 out of 10. So here the random variable takes the value xi is denoted by pxi. For any discrete random variable xi, the number of pxi must satisfy the following two conditions. So in order that this probability exists, the two conditions must be met. Otherwise, this probability will not be valid. How? So here 0 must be less or equal to pxi, and also pxi must be less or equal to 1 for each I. Let's see how. For example, here we say 0 must be less to pxi, like this, and pxi must be less or equal to 1. What does it mean? The probability probability value must not be greater than 1. It means this is 100%, like this, 100%. So the probability range must be between 0 and 1. So, for example, I am having the probability of having x0, the probability to have a value 5 in x0 will be equal to, must be less or equal to 1 and greater than 0. Here it means that I'm having 0 less than the probability of getting pxi like this. This is pxi like this. So I put px0 must be less or equal to 1. So here I am having 0 must be less than the probability of getting the value, the probability of getting the value at px0 is 1 out of 10, because we are having only once the value of x0, so it is 1 out of 10, and this must be less or equal to 10. So we can check if this condition is met. So this condition is met because 0 out of 10 is greater than 0 and less than 1, like this. The second condition is that if we add or the probabilities, it means that the total value of the probability will be equal to 1. How? I must be going from 1 till the infinity. So here what we say here, the probability of having px0, probability of getting px0 is 1 out of 10. The probability of getting value 1, it is 1 out of 10. The probability of having x9 is 1 out of 10. If we add them, it means that it will be equal to 10 out of 10. It means that I'm having p x0 plus p x1 plus, we continue till p x9 like this. It must be equal to 1, or it must be equal to 100%. So if those two conditions are met, it means that this probability is valid, otherwise it won't be valid. Another concept is about the correlation of pairs. We can have a correlation of pairs. We can have a correlation of pairs xi, pxi. We are having for each value in the x and the probability of getting such value. So I is running from 1 to till the end. This will be called as a probability distribution of x. This xi is the probability distribution of x, and pxi will be called the probability mass function. This is a function, this one, pxi is a probability mass function, and xi will be called probability distribution of x. It means the number of value x can hold, and the probability of getting such numbers in that range is called the probability mass function of x. Let's take an example. The number of people arriving to a bank at a particular day in a random variable is a random variable, say x. Here we're having the number of people arriving to a bank. For example, today, on Thursday, the number of people arriving to a bank, for example, Bank of Kigali, we say that we are having 100 people. This will be a random variable. Why we call it a random variable? Because we don't know which people will come, and we don't know which time they will come. So the people will come randomly. So you can't say at 9:30 two people will come, at 9:31 another person will come. We don't know. So that is why we call this variable a random variable, because it will hold any number of value which will be taken randomly. So the range space Rx will take from the value 0, 1, 2 till n. Another example, we consider an experiment of tossing a single die. Tossing a single die. This is a die. We are having two dice. A die is used in a game. It means that it is used for random games. It is almost the same at what we call Urusimbi in Kinyarwanda. So here this die is not complete. Let me show you an exact die. Must have six dots here, 6 dots at each side. It is like a cube, and each side each side must have a values which range from 1 to 6. The first side we have only one dot. The second will have 2. The last one we have 6 dots. This is the last one. This is the fourth one. This is the 51. So the value when you are going to throw to toss or throw, when you are going to throw or toss a die, the value which appear on the top, it is those values which will be considered. So, for example, the man has tossed this die like this, and the value which came on the top is 5. This one, when he tosses this, the value which will be on the top will be 3. So only these values are considered. This one, this, and this one. I think you have played such type of games like this. It is like Urusimbi in Rwanda. So they will be the tossing of die is one of the main studies in the probability. You can say that what will be the probability that value 5 will be shown at the top of a die, or which the probability that the value 3 will be shown at the top of a die. So this is a very good example of a probability function which will show how probably a given value will be appearing in our probability distribution. So here we are having the same example. Example 2, we are having, consider an experiment of tossing a single die. It is obvious that the possible outcome may any one of the number from 1 to 6. It will be from number 1 to 6. If the top side is having value 1, okay, but you can't have the top value with 7. It means that because we are having 6 sides, so the possibility of getting one side at the top, it is 1 out of 6. So the random variable x will be the value that appears on the top of a die. If you toss a die and you have a 3 at the top of the die, it means that x will be equal to 3. So the range space of a die, of tossing a die, must be 1, 2, 3, 4, 5, 6. 7 is not there because we are having only 6 sides. This is the range. One can observe that the probability of getting any number on the top, it is 1 out of 6, because the probability of getting the value 6, it is only one probability. That is why we are having 1 out of 6. But here let's toss 2 dice at a time. If we toss 2 or we throw 2 dice in the air at the same time, 2, what will happen? The random variable x will be the sum of the numbers which appears on the top of the dice. It means that if you throw them, it means that the side which will come at the top will be 2. 1 for each die. So the possible numbers that may appear on the top of 2 dice would be a set of ordered pairs. So what will happen? For example, for dice 1, this is the sum. For the dice 1, for the die 1, the side 1 can appear at the top. For the dice, the second dice, the side 1 also can appear at the top if you throw them at the same time. Or another probability is that the side 1 of the first die can appear at the top, and the side 2 of the second die can appear on the top. The last one, we will see, if you continue, we will see that another probability, the last probability will be that the side 6 of the first die can appear at the top. At the same time, the side 6 on the second die appear at the top also. No problem. These are a set of probabilities which can happen when you toss 2 dice at the same time. This is the range of the tossing of 2 dice at the same time. So the range space of x contains the possible sum of the ordered pair of the set. So what we are going to have a range, we have to add the 2 sides which are shown at the top. So the first one, we add these 2 side numbers. 1 plus 1, it will be 2. 1 plus 2, it will be 3. The last one, 6 plus 6, it will be 12. This is the range space of x, because we have thrown 2 dice at the same time. Now let's continue with continuous random variables. This is the second type of random variable. If the range space Rx of the random variable x is in an interval or collection of intervals, then x is called as a continuous random variable. Here it means that we are having the range space of x, which is called Rx, for the random variable x. We will call it is continuous when x is in an interval or collection or interval. This will be called continuous. Why is it called continuous? It means to continue changing a value which range from that interval. Here we can have x which is a continuous random variable, and have also its probability that x is in the interval a and b. For example, we can have a random variable x will be continuous if its value are between a is 10, for example, and b 100. So if x is in this interval between 10 and 100, then x will be called continuous random variable. For example, here the probability that x is in this interval will be noted like this: p a less or equal to x and x less or equal to b. You can write this, or you can write it like this. So if you use the probability that x is in the interval a and b, it must be greater or equal to a and less or equal to b. Or we can write this using the integral function. So this is the lowest range and the highest range. Function f of x dx. If we have this integral like this, it means that the value of x is ranging between a and b. So the function fx, this one, is called the probability density function. Why it is called density function? Because it will hold the range of values, or it will hold a list of values which range between a and b. So the PDF must also satisfy some condition. Which one? 0 must be less or equal to fx, and fx must be less or equal to 1. Why? Because the maximum value of each probability function is equal to 1. So fx must be less or equal to 1 for each x pertaining to range x. If you go out of range x, you can have a value greater than 1. So this is not valid. The second condition is that using integral we have a set of a range of values. Here, if we type here, this Rx will replace A and B here. So fx, when the value of x ranges are in the range Rx dx, it is equal to 1. It means that whatever value we have as the result of this function, the value must be, if we add them, the maximum or the total value must be 100%, which is equal to 1. So if we have fx0 is equal to 0, so fx will be equal to 0 if x is not in the Rx. If I have x, for example, I must have the value a is equal to 10, b is equal to 100. So I have x is equal to 120. So the 120 is not in the range of 100 of 10 and 100. So if I have x is equal to 220, x is not in the range of Rx, immediately the function results will be 0. So for any specified value x0, the probability is 0. If we have a value of x0, if we start from x0, it means xr is equal to 0. Immediately the probability will be 0 because we have nothing. Because if we put x0, this is the lowest value of the range, this is the highest value of the range. So the lowest value of the range and the highest value of the range, if they are equal, immediately the result of the function will be 0. So as the probability of x is equal to x0 is equal to 0, same like this, we can write it like this or this one, no problem. So if we have the probability that x is equal to x0, so it will be equal to 0, the following equation will hold good. Why? Because whatever we put, if we put the sign less or equal or less, if we change, if we interchange them, there won't be any problem, because for x0 the result will be 0, so there won't be any change. For example, here I am having the probability a is less or equal to x and x less or equal to b. This is the same as we write a less than x and x less or equal to b, no problem. It is also the same if we write like this: probability a is less than or equal to x and x less than b, no problem. Even you can remove the equal sign, so it will be the same, no problem. Another notion you can have here, you can have a cumulative distribution function. A cumulative distribution function, as its name states, the cumulative, it means that we are having a cumulative values, or we are a correlation of values which are combined. So here we can have the probability that a random variable x having the value less than or equal to x is called cumulative distribution function. It means that we can have a probability that the variable x, which is uppercase, can have the value of x which can be less or equal to x itself. It means that we are having a random variable which is going to take any values, but there is a probability that the uppercase x can have values which are less or equal to x. Let's have an example here. I'm having the big x like this. It is having the value which is equal to 1, 2, and 3, 4 like this, and small x small x is equal to 3. So what is the probability that x is equal to 3, or big X is equal to small x like this. I'm having big X like this: 1, 2, 3, 4. 1, 2, 3, 4. What is the probability that P, the X, big X is equal to 3, or big X is having the value less or equal to 3? Where? Which is the probability? Here we are having the probability. We are having the 3 probabilities here. So here we are having the probability is that the big X is having the value less or equal to X. Here the first probability is this one. We are having the probability that we have a value which is less than 3. Here the first case is 1, the second case is 2, the third case is 3, like this. So this probability can be denoted as cumulative distribution function because it will have a collection of values which can be held in uppercase X and less than X. So we denote it as Fx. So Fx will be equal to the probability that the variable X holds the value less or equal to small x, like this. If X is a discrete random variable, then Fx, if X is a discrete random variable, then Fx will be equal to the summation of all values which can be gotten by I, starting from 0 to the last value Pxi. It means that we're going to add all the probabilities. We add the probabilities. So here we are going to have Px0 plus Px1 plus Px2. So this function will be cumulative because it is the summation of all probabilities which we got. Here we are going to see another concept, which is an expectation. In an expectation, it is like an average. So in mathematics, expectation of a random variable x is also known as a mean. Here we can say, mathematics, you can say average, mean, and so on. So we call it expectation or mean. We going to denote it using this notation. This notation is going to mean the expectation or the mean of a range of values. The expectation is going to be denoted like this one or this one, but here we are going to use this notation. For a discrete random variable x, is expectation is equal to the summation of all values of x multiplied by the probability of for x to hold the value xi. So let's take an example like this. So let's see an example here. I'm having x, this is a random variable. Xi can be x0, x1, x2, x3, like this. So x0 can have the value 2, x1 value 3, x3 value 2. The probability to get x0, the probability to get the value 2 can be 1. The probability to get the value 2 here for x3 is equal to 1. So using this formula, this one, xi multiplied by pxi, the summation of all of them. So what we have? We will have this expectation will be xi multiplied by pxi, which will be equal to x0 multiplied by px0, like this, and x1 multiplied by px1, and x2 multiplied by px2 plus x3 multiplied by px3. So it will be 2 multiplied by 1, 2 multiplied by 1 here. This is x0 multiplied by px0, and px3, this will be 1, and x3 is 2. So it will be this 2 multiplied by px3, which is 1 here. So the summation will become the mean, or the expectation, or the average. So this is an example of this function. This will be for discrete random variable. An expectation for a discrete random variable will be calculated like this. An expectation for a continuous random variable, we are going to use integrals. We will go from the range of minus infinite to plus infinite, x multiplied by fx. So it is almost the same as what we did here. We're having a xi here, we take x multiplied by pxi, here we multiply by fx. It will be the same. So the expectation is also called as the first moment of x. The expectation, we are going to call it as the first moment of x. It means x can appear multiple number or multiple moments. So the first appearance of x is the expectation. So the nth moment of x is computed as, for example, we can have the fourth moment of x. It means the fourth time the value x has appeared. We can calculate it as like this. We must have the summation from x starting from I, it can be 0 till n. So we take xin multiply pxi if x is discrete. So if we are having any number of occurrence of x, we can calculate the expectation using this formula here. But for a discrete variable, for a continuous variable, we are going to use the integral from the range minus infinite till plus infinite x power n fx dx, this one. So from that we can also calculate the variance. So these are the notation from the statistics. The variance will be denoted as vx. Then how we calculate it? The variance will be equal to expectation, which is in evidence. If we are able to take x minus expectation power 2, if we find this one, this is equal to, it is almost the same. We can take this. You can see that this is an expectation we are going to calculate, and the expectation of x power 2. It means that what we have done here, this power 2 is on two sides here. So this is x power 2 here. So we can take this part and put it apart, this one. So we take x power 2 because this 2 is also here because of this parenthesis here. So we are having x power 2, it is this one, and also this expectation must come here minus this part which remains, which is this one. So we can write it like this, no problem. You can also calculate the standard deviation. The standard deviation, it is what? It is the root of variance. When we find the value of the variance here, the standard deviation will be the standard deviation will be the root of the value we get here. If we here we get, for example, 4, so the standard deviation will be 2. We can see another concept which is a mode. A mode in statistics is a measure of central tendency. It will be used to describe several statistical models. We can have 2 cases. The first case is when you have a random variable. The mode, when you have a random variable, the mode is the value of the variable which occurs most frequently. In other words, it is the value of variables which has appeared more than one number of times in a given list. This is the first case. You can see here. Here I am having the value 2, 3, 1, 2. So what will be the mode? It is the value which will occur more number of times. Here the mode here is 2. Then this is in the case of discrete random variables. Discrete random variables. For continuous random variable, the mode is the value at which the PDF probability distribution function is maximized. It means that the way we have this function having a high value. So here we can have some more note. We can have 2 modal value. If we have 2 modal value, for example, we are having a list of values. There are 2 values which occurs twice. So we have 2 modal values. So this distribution will be bimodal distribution because we are having 2 modal values. So here we are going to see some uses for statistical models. There are so many models in statistics. So here, while you are developing simulation models, you have to choose which statistical model you are going to use. So you have to choose which one, which suits your needs. So the analysis may require to generate random events. It may require to generate random events, and for example, you have to generate how customer randomly join the bank, and how randomly or how the service time will be required, and identify statistical distribution of those events, and then he has to use statistical models. So it means that when you are analyzing the system, for example a bank, you are going to study how people are coming to the bank, how they are being served, and how they are quitting the bank. So those events will be random. So we can represent such events using the statistical models. So the usage of such statistical model will depend on the type of the event. So for example here we are going to see what is called a queuing system. A queuing system is what? Is a waiting line. For example, people are waiting in a queue to get a ticket. So you are going to buy a ticket at a store. So not the counter won't give the ticket to all people at the same time. So you have to go into a waiting line, a queue. So we can calculate the total service time which will be spent by the counter to give all people present the tickets. So here there may be one or more counters. and the number of people waiting in a queue is dynamic. It means it is changing because some people are entering the queue, others are quitting, so the number of people in the queue will be changing. It will be dynamic. So a queuing system will be described by what? The population. The population means the number of people in the queue. The nature of arrival. We can have people can come randomly. And also the service mechanism. Service mechanism, you can say, for example, the counter will serve one person at a time, but will start from the one who came first, like that. And then the system capacity. It means that if you are having a very small room where you are having a few seats where the waiting customer have to sit, it means that when there is a very big number of customers, some will stay outside, for example. So this also will depend on the capacity of your waiting room or the queue. And also it will depend also on the queuing discipline. Queuing discipline, it means that you can say first come, first out. It means that the first who came first, he must go in the front of the queue, and the last one must go behind others. It means that the queuing system, it will depend on the population, the number of people, the natural, the service mechanism, the system capacity, and the queuing discipline. In the queuing system, enter arrival and service time button will be given. Here, when we are going to analyze the queuing system, you must know enter arrival. Enter arrival means that what is the time between the arrival of one person, between one person and the following one. The service time, it means that we calculate the mean of the service time to one customer. You can calculate the unexpected mean service time for one customer, and these two values must be given. So the time between arrival and the service time are probabilistic. It means that you won't expect in advance what will be the time required for people to arrive and what time a person will spend at the counter. These are approximation, probabilistic. So the distribution of time between arrival and the distribution of the number of arrival per time. You can have the distribution between arrival and the distribution for the number of arrival per time period are important in a simulation of queuing system. So this is very important. The time between arrivals and the number of arrivals per time. It means that I am having one person is coming 8 o'clock, the second one is coming 8:30. This is the distribution between the arrival. The distribution of time between the arrival, there's two arrivals, is 30 minutes. And also you can calculate the number of arrivals per time. For example, you can say in 1 hour 10 people are coming, for example, like that. So these are very important. It must be provided in your distribution. So the distribution that switch queuing system may depend on the following situation. It means that we can have different queuing system of different queuing system having the different kind of features. So we are going to use a distribution. We are going to use a distribution according to the queuing system that we are having. For example, if the service time is completely random, the exponential distribution is suitable for simulation purpose. If we are having a service time which is random, it means that you can serve anybody. We are going to use exponential distribution. This is found in statistics. For example, here you can have an example. the time required to get a task done at the government office is random. It means when you are in the government office, you don't know the time which you will require to have a task or your duty done. So it will be random. So it will depend about what? About the task type and the person also. If the task is very difficult, so it will take a long time. If the person is very slow or he doesn't know, he's not a professional, it will take a lot of time to complete the task. Also, we can have here we use exponential distribution because we don't have exactly we don't know at the advance what time we required to complete the task because it will vary. So if the service time at the beginning of the system is low, is low, and it will increase as the time passes, and when reduce at the end, we are going to use normal distribution. Normal distribution is a distribution which is like a distribution which is like this. In the morning, we are having a very low rate, for example, of people. At midday time, they increase. At the evening, they decrease like this. So this distribution is normal distribution. Exponential distribution, we can have a distribution which we vary randomly. So for example, here we can have an example here for normal distribution. You can have the service time at the bank in the morning hours is less because in the morning there are few people. So after as the day, as at the mid time we have too many people around 11 o'clock and so on and 12 o'clock. In afternoon also people will decrease. So the morning less, at mid time they increase, they reach the maximum, and the evening they decrease. So we are going to use a normal distribution. We can have also some example using a inventory and supply chain system. We are in a production company. This production company is manufacturing products or some components. Say, for example, car parts. So here there will be a supply chain. Here we can have three major random variables in inventory in the supply chain system. So, for example, here the number of units demanded per order or per time period. Here we can calculate the number of units or the number of components which has been demanded by the customer by one order or in time period. It means that, for example, a company is ordering some products from you. We can calculate the number of units ordered per the order number one, or we can calculate the number of units which have been demanded in 30 last days. So here it will be per time period. Or we can calculate also the time between. This is the random variable. The time between the demands also it will be a random variable. Why? Because you don't know. You can't predict what will be the time between two demands. It will depend on the customers. Also, you can create the time duration between placing an order and receiving item. You can calculate also the time duration. You can't expect that the time between placing an order and receiving the item will be will be unchanged. It can change. It will depend on various factors. If there is a heavy rain, the shipping company will take a longer time to bring the items. So these three variables can affect our distribution. Again, you can talk about what is called reliability and maintainability. Due to failure has been modeled with various distribution, like exponential, gamma, and Weibull. Exponential distribution will be used when we have random failures. It means that you can have some devices which are failing. For example, you are having a generator, it is not working properly. So you can't predict that today the generator will fail. So here the failure will be modeled as exponential because we are going to have a random variable. You can also use a gamma and Weibull distribution, no problem. So we can also model standby redundancy. So for standby redundancy, we can have gamma distribution. But when there are a large number of components in the system and the failure is due to a large number of defects, Weibull distribution will be used. This Weibull distribution is used when we are having a large number of items, or when we are having a large number of values. So you use this one. If you use exponential distribution, it will be the problem because this can't handle a large number of values. So this one will be used. We can also have a limited data. Here, how? Because simulation model sometimes it begins before the compression of data collection. So when you are studying your system, you start from studying the system by defining the problem. When you are doing that, you have also to start the data collection. But here, modeling, it begins before the complication of data collection. It means that the simulation modeling will go with the data collection operation. So sometimes you will finish modeling your system, but there is still some data which must be collected. So in such a case, you will have a limited data, or you are having a few data. So if you are having a few data, use this distribution, uniform distribution. You can also use triangular and beta. So we will see this distribution in the later chapters. So here it means that when you are having a few data, you use this distribution, this one. But when we have an inter-arrival time or service time is random, we are having inter-arrival or service time which are random, you can also use this one, uniform distribution. Can also be used here. But we are able to use a triangular distribution when assumptions are made about the minimum, maximum, and the modal value for the random variable. It means that the triangular, we are going to use it when we have approximation. Approximation about what? We don't know exactly the value of the lowest and the highest value, or the model, the value of modes. If we don't know them, or we are having an approximation of such values, you can use a triangular. So the triangular distribution is used for approximations. So dear students, continue reading this. This is the second unit. So the next video will talk about discrete distribution, and the second video also will be about the second unit. So you have to read step by step. Thank you.